Right, let's do some Pythagoras Theorem. And Pythagoras Theorem, as you probably know, is to do with finding the length of a side on a right-angled triangle. And this isn't to any triangle; it's specifically to right-angled triangles. And it's been proven using right-angled triangles. It can't be used with any other type of triangle. So let's just go over what I've written here. Pythagoras' theorem, in words, what Pythagoras' theorem is the square of the hypotenuse. I'm going to explain what the hypotenuse is equal to the sum of the squares of the other two sides. And sum just means add, so we just put add there. Hypotenuse, I'll explain what that is, and the square, that just means you square them. So 2 squared is 2 times 2, which is 4, that kind of thing. So what is the hypotenuse? If we look at a right-angled triangle, here's a rough drawing of a right-angled triangle, and you always know it's a right-angled triangle because it has a square box in one of the corners, and what that square box means is that you've got 90 degrees there. So you've got 90 degrees there, and if your triangle has an angle which is 90 degrees, then you've got a right angled triangle. That is a right angled triangle. If it has if you've got a 90 degree angle, that is a right angled triangle. And what the hypotenuse is, the hypotenuse is the longest side of a right angled triangle. Okay? And for example, in this one, this length here would be the hypotenuse. Another way to pick it out would be to say that it's opposite the 90 degree angle. So the hypotenuse is always opposite the 90 degree angle. Here's our 90 degree angle, here's our hypotenuse. So that's 2 ways: the longest or opposite the 90 degrees angle. You decide which way. Now then, just to bring our attention back to this, so what this is saying is that if you know 2 of the lengths on the triangle, then you can calculate the length of the other side according to this rule, according to this law of right angled triangles. So say you had the length of this side and the length of this side, you could calculate this side. Or vice versa, if you had this side and this side, you can calculate that side. If you had that side and that side, you can calculate that side. Okay? So, you can also express this in terms of algebra. Algebra is just letters. It's nothing to be scared of, it's just letters. And this expressed in algebra is a squared plus b squared is equal to c squared, where c squared is the hypotenuse, the longest side of the right angle triangle. C squared is the hypotenuse. Okay? So, for example, if I was to write this out like this side, there's a right angle sign, this side is C, and it doesn't matter, either side can be A or B, it doesn't matter. Say have A there and B there, or you can have B there and A there. It doesn't really matter, as long as your hypotenuse is C. It doesn't matter. So, to calculate C, you could square A, square B, or square the 2 sides, add them together, and you get C. Or say you've got C and you want one of the other ones. What you'd have to do is square the hypotenuse to get your value of hypotenuse, square it, and then take away the squared value of your other side. So you'd get C squared take b squared equals a squared, for example. You would have to do that. But that will become clear when we do some examples now. So, to remember, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Basically means if you square two of your known sides, and then if you're trying to find the hypotenuse, add them together, then you have to square root it. You've got to remember to square root your end result, because you're after c if you're finding the hypotenuse, not c squared. So you have to square root your end result as well. And then say if you've got your hypotenuse, square both sides still, but take your other one away from your squared hypotenuse value. So let's do some examples. This is a good example. So let's use this. First we have to identify the hypotenuse. Remember how I said to identify the hypotenuse, either the longest side or opposite the 90-degree angle. This side therefore must be the hypotenuse. So we're after this side. This side is c. So a squared plus b squared equals c squared. And we can label these a or b as we wish. So I'm going to say this side is a and this side is b. You could have it the other way around if you like, it doesn't matter. So this says to square a, okay, so 4 squared, then add it to b squared is 5 squared, is equal to c squared. Now what is this? 4 squared, 4 times 4 is 16, plus 5 squared, 5 times 5 is 25, is still equal to c squared. Add these together and you get 41 equals c squared. Now you're after c and not c squared, so you have to square root it. So c is equal to the square root of 41. Simple. And that's in meters. So meters here. To bear in mind your units. Now for this one. This one's different because we've got the hypotenuse. The hypotenuse is this one. This is our hypotenuse. It's opposite the 90-degree angle, and it's the longest side of our right angle triangle. They do give different orientations of a right angle triangle. Don't let that confuse you though. So, write our formula again. A squared plus b squared equals c squared. We know that this is our hypotenuse. Label that c. And it doesn't matter. A, b. You could have it the other way around if you like. So, a. We don't know what a is yet, so if we just stick that in, plus b squared. We know b is 3. 3 squared. b is equal to 3. And we want b squared, so 3 squared is equal to c squared. We know that c is 5. We want c squared. That. So, how do we get a? Well, we have to rearrange this to get a. So we get a squared is equal to 5 squared take away 3 squared, which is equal to 25 take away 9, which is equal to 16. Now then, we want a and not a squared, so we have to square root that. So a is equal to 4 millimeters. Cool. Another way to think about that as well is that when you take away stuff, you always take away the smaller one from the bigger one, because otherwise you'd have a minus number. So if you think about it like that, hypotenuse is always bigger than, if I've got a hypotenuse value, I always take away. The hypotenuse is always bigger than my other side, so I must take away the other side from my hypotenuse. Okay, I should always take the square of my other side away from the square of my hypotenuse. Sorry, that would cause some confusion. Good. Now then, this is a bit of an extension-y question. They could bring algebra into it. And if you haven't reached this level yet, if you've only just started Pythagoras, I'd pay no attention to this, but just if you want to stretch yourself, I'm going to go through some of this as well. And you just attempt this exactly the same. First, identify your hypotenuse. The longest side or opposite your 90 degree angle, this is your hypotenuse. This length here. So, write out your formula again. A squared plus B squared equals C squared. This is your C side. A, B, again it doesn't matter. You know, A is 3x, so what you want is 3x squared plus 4x. 4x squared is equal to C squared. Now what is this? What this means is you've got 3 squared, which is 9, and then square the x, which is just x squared, plus square the 4, 16, then square the x squared is equal to C squared. Add these together, because if you've got 9 sweets and 16 sweets together, you've got 25 sweets. So let's get in with x's. I've got 9x squared and I've got 16x squared, so together I've got 25x squareds, and that would be equal to C squared. I want C, not C squared, so C will equal square root of 25, which is 5, and square root of x squared, which is x, and that's in meters. Again, if you didn't know what I was on about there, just ignore it. But if you wanted to stretch yourself a bit, that's just applying Pythagoras' theorem to a different type of question. And I hope that was okay.